In this video, I'm going to show you the processes to recap the past Labs X250. And if you own one of these or you plan to own one of these, so I highly recommend you to recap the power supply capacitors. The reason is that I measured the power rails and they are around 53 to 55 volts, while these capacitors are rated 50 volts. And they tend to fail prematurely, and especially consider the environment, right? So this is very hot in the chamber, so it would make it capacitor dry sooner than expected. And so you can see the main power supply capacitors contains two main sections. One is underneath the board. You can see there are 12 of them, 10,000 microfarad, 50 volts. And then on each board, you have four same value, 10,000 microfarad on each of the board. And another four capacitor you want to recap are the smaller ones. You can see these are 1, 2, 3, 4. So two on each board. They are 220 microfarad. So I'm going to replace them with slightly higher value. I'm going to use 15,000 microfarad, and I'm going to use 63 volt rating capacitors. So it will be bigger than these. If you look at the later past lab amp, for instance the X250.5 or X250.8, they start to use bigger values, 22,000. And the reason for that is to focus on the mid-range decoupling, make the amp sound more precise in mid-range, better sound imaging and sound stage, and so on and so forth. There are smaller capacitors for high frequency, but those they are not electrolyte capacitors, so you don't have to replace them. Those are for high frequency purpose. After recapping the amplifier, you definitely want to do DC offset adjustment as well as the bias adjustment. So in this picture you can see the smaller input board. There are two ports on each board. Those are for the DC offset on the output, and one port is for the absolute offset from each leg of the output to ground, and the other is for the differential offset between the two legs at the output. So you need to be very carefully adjust those, because a tiny adjustment will change the offset significantly. Normally you can adjust within 10-20 millivolts should be sufficient. For me, I did a little bit more crazy, like go into single digit kind of offset. You don't have to do it, because a few tens of millivolts doesn't affect anything. And then after that, you want to adjust the output bias. Again, on each board there are two of them. You can see one on the right hand side, one on the left hand side, and the other board. So this is total full differential. That's the reason they have two boards, one for the positive polarity and the other for the negative polarity. So each of these ports adjusts the positive side of the transistors and the other for the negative side. So you can see the resistors are in two groups, and the way you adjust them, you just slowly adjust the port and meanwhile measure the voltage on the output resistor. There are slight differences because the transistors are not perfectly matched. So the target is 60 millivolts after warm up. So anything between say 50 millivolts to 60 millivolts should be okay. The power supply board is fully recapped. Relatively straightforward. Remove the original one, which is I think it's Panasonic, and replace its Rubycon here. So on the bottom there are 12 of them. So next I will move on to the remaining 8 capacitors and the smaller ones. The capacitors on the main board are also recapped. These are the new Rubycon capacitors. And again, the smaller one originally was 220 farad, was replaced with the bigger one, 1500 microfarad. So 2 on each channel, 2, and then 4 large capacitors on each channel. Once completed, power it up and settle for 20 minutes or so. Remeasure the output offset and the bias. The bias across the resistors should be roughly 60 milliamps on each. But basically because of a slight variation of the transistor, so the voltage may vary from say 50 to 60 or something like that. That should be totally fine. And the offset, you notice there are 2 ports to adjust. One is for the offset between ground and output, because this is differential output, and the other is to adjust the pure DC offset between the 2 terminals. So normally I put it under say 20 millivolts should be sufficient. In my adjustment, it's about roughly a few millivolts, but you don't have to go that precise because these ports are very sensitive. A tiny move tend to change the value significantly, so be careful.